Hello students and friends, welcome to my YouTube channels. Today I am going to discuss the support reactions problems. Already before these two support reactions problems we discussed in the both previous problems basic concept. Now in these problems what I am taking three load, point load also, UDL also, UVL also. So this will easy steps I will solve now. Okay. So before this we have to discuss UDL and UVL. How we'll take the UDL and UVL, how it will act. So see here, this is called UDL. UDL symbols will be either this or symbol will be this. Both are same. So here W kilonewton per meter weight, W kilonewton per meter weight, length L. So look here, both are same. Symbol will be different. So what is the middle point for this? Where will the load act? Load will act in the middle point only, because this is called rectangular load. Or if you will see the deflection is coming in the middle point. That means load is acting in the middle point. Suppose we will draw the load diagram. This we can write W into L. Distance will be L by 2. Total distance L. So load acting always middle point. Load acting always middle point for the UDL. Similarly, now come the UVL. Similarly, now you come the UVL. This is the UVL. Triangular load, also known as triangular load. Suppose this will given W kilonewton per meter load. Length will be L meter. Length will be L meter. So how to convert the load? Load is nothing but area of the rectangle. See here. This load, now how we wrote load? W, area of the rectangle, length into this breadth, WL. Here also how we write the load? Area of the triangle, what is 1 by 2 into base into height. So L into W. So this is called load. This is called load. 1 by 2 area into height. So area of the triangle, you remember, area of the triangle 1 by 2 B into H. So L into this load. Now where will the middle point act in the? Where will be the center of gravity point for the triangle, you can say. Rectangle center of gravity, you know, middle point. But where is the center of gravity point for the triangle? So that only you have to learn here. So approximately center of gravity will be lies near the bigger area. Why? Because center of gravity nothing but entire triangle load will act at that particular point. That is known as center of gravity. So generally center of gravity will not be here, not be approximately center of gravity bigger area or near the base. So somewhere, suppose center of gravity will be somewhere here, CG point. What am I going to explain? How to reach this point from the, suppose you are in here, in this point, how to reach? You have to travel this distance, you will reach the center of gravity point. Suppose you are here, you will travel this much distance, you will reach the center of gravity point. Suppose you are here, if you want to travel this, you will reach the center of gravity point. From here, you have to travel here and reach the center of gravity point. So what we should know here, from here, the center point distance how much? From here, center point distance how much? From here, center of gravity point distance how much? From here, center of gravity point distance how much? That only we have to learn. So again, you will see this here, one triangle. So we have to be here. How will reach here? So suppose this is length L, this is B. If we are traveling from this way to the center of gravity point, to the CG point, this length will be 2H by L either, no? So 2L by 3. If you are moving from this distance is equal to L by 3. So if you will add 2L by 3 plus L by 3, how much coming? L. 3L plus 3 is equal to L only. So total distance is L only. That means if you are here, if you want to reach this point, you are traveling 2L by 3 meter. From here you are traveling from this point L by 3. From this side if you are traveling 2B by 3. If you are traveling from bottom, B by 3. B by 3. This way L by 3, you write here. If you are traveling from this way, you can write L by 3. If you are traveling from this way, you can write b by 3. If you are traveling from this way, 2 by 3. Where you are traveling? To the center of gravity point. So this distance from here to here, 2 by 3, b by 3. Here 2L by 3, from here L by 3. So we can reach the center of gravity point. Why I explain this? Once I solve these questions, you will know this concept. Okay, so now you come, first we'll draw the load diagram. First we'll draw the load diagram. First we draw the load diagram, and all the load will convert into point load. All the load will convert into point load. Then easily we can solve our questions. That is the simplest method. You can solve directly also. Lot of things you have to understand, remember. So it will be little complicated. This way you can solve without any hesitation, without any tensions. Okay. So now this is the support reactions RA. This is the support reactions RB. Now look here. UDL is there and one load is there. First this load. Point load, now directly you can write 6 kilonewton. Now UDL is there. So UDL I told middle point, center of gravity will act middle point, and load will be nothing but length into breadth, area. So 8 into 4. It will act in the middle. It will act into middle. That means 8 into 4. What is this one? Load. 8 into 4. It will come kilonewton. 8 into 4. Kilonewton meter into meter will get cancelled. 8 into 4 kilonewton. This length is 2 meter. This length is 2 meter. So what we observe here? UDL load diagram, once you are converting, that load is acting in the middle, center of gravity point. Okay. Now this point load as it is, right? 10 kilonewton. This will come to 32 kilonewton. Now this distance you write parallelly 2 meter. This is 1 meter. This distance is 6 meter. But first load will convert 1 by 2 into L into W. So what is here load? Load we can write here what is 10 into 6. This is 6, no? 6 meter. 1 by 2 into 10 into 6. How much? 30 kilonewton. How much it will come? 30 kilonewton. How much it will come this one? 30 kilonewton. Load will be 60. 1 by 2 into, yes, 30 kilonewton. Now 30 kilonewton where will act? 30 kilonewton where will act? We have to reach the center of gravity point. So see this diagram, this way is there. So this distance you have to travel. So 6 is there, no? So substitute here. 2 into 6 by 3. How much is coming? 4. So from there, this will come 4 meter. If will come this side, 2 meter. So what will act here? 10 into 6 by 2. So what is this one? 30 kilonewton. So what is load here? 30 kilonewton. Okay. So load diagrams over. Load diagrams over. So new load diagrams over. Point load. This also point load. This also point load. This also point load. What you have to careful here? UDL middle point 2 2. UVL you have to go the center of gravity distance from this distance, because this directions will be like this. If you are coming this side 2 meter, if you are coming this side 4 meter, you are reaching the center of gravity point. Now point load over. Now our simple problem. Our simple problem. What will do simple problem? Write the two equilibrium equations. Sigma F equal to 0. Total upward force equal to total downward force. What is upward force? RA plus RB. Two upward force. Downward force 32 plus 6 plus 10 plus 30. What is 30? Load. This I know now. Now just you calculate this, how much? 32 plus 30 plus 16. Directly I'll write. It is coming 78. 78 kilonewton. Give equations number 1. This thing is not required. Rub it. This is the 78 kilonewton. Okay. Now moment about A. Now just treat like a point load problem. Now look, this load diagrams how we draw, that only you have to careful. Now treat like a point load problem. So what is this moment? 32 into 2. What is this rotation? Clockwise. 6 into 4 plus 6 into 4. What is this rotation? Clockwise. Plus 10 into 6. 10 into 6. What is rotation? Clockwise. What is rotation? Clockwise. Plus 30 into total distance here. 4, 5, 7, 7 plus 4, 11. All loads over. This also clockwise. Is equal to RB into total length. Total length how much? 13. Total length is 13. Now solve this. 32 into 4, 64 plus 24 plus 60 plus 11 into 30 into 11, I think 330. 330 is equal to RB into 13. Now total you will add. Total you will add plus 60 plus 24 plus 64 is equal to coming 478 divided by 13 is equal to RB divided by 13 is equal to 36.78 kilonewton. Substitute this RB in equation 1. Substitute RB in equation 1. So RA will come 78 minus 36.78. RA plus RB. RB you substitute here. It will go this side minus. So 78 minus 36.78 becomes 41.22. 41.22 kilonewton. That is called RA. So RA and RB we know now. So RA is equal to how much? 41.22 kilonewton. RB you know 36.78 kilonewton. So this way we can calculate. So one more time this triangle I will explain. See here. Suppose this triangle is like this. Okay. Same dimensions I am giving here, 10 and 6. So how we wrote this 30 and load? So first load na area of the triangle 1 by 2 into 6 into 10. Okay. So how much this one? 30 kilonewton. 30 kilonewton we know the load. Now where that load will act? UDL load is acting middle. Where will the load will act? So once we are seeing from this to center of gravity point, 2 into 6 by 3 writing. That's it, 2L by 3. From this side, 6 by 3 you writing. If you are going this way, if you are coming this way, you write 10 by 3. 2 into 10 by 3 because 2 into 10 by 3. And this way if you are going 10 by 3. And this way you are coming this way, this for this side. If L is there, 2L by 3. So if you will add this, suppose this is L, this is B, what is there here? 2L by 3 plus L by 3. Finally it will come L only. 2B by 3, B by 3, finally will come B. That means 2 trick is there. A smaller section, center of gravity will be bigger length. A smaller section, center of gravity bigger length, because center of gravity nothing but entire body weight. Entire body weight will be where? Near the base. Near the base only. So from this side, I am seeing from this side, center of gravity length 4 meter. If you will see from this side, 6 by 2. In this side, 2 into 6 by 3. 2 into 6 by 3. So it will be 4. So this way you have to remember. Okay. So once you know this load and where the load will act for the UVL, that is matter over. Convert into point load and solve these questions. Okay. Okay, students. Thank you.